So in this video, we are going to look at derivatives of the natural log function and the exponential function, and we are also going to look at logarithmic differentiation. So the derivative of e to the power of x is e to the power of x, and the derivative of ln x is 1 over x. But whenever ln x is involved, please pay attention to the domain. So I'm not going to specify the domain restrictions in any of these problems. That is something that you should always be mindful about. So this derivative is, so we have to apply the chain rule here, but you can also use the properties of logarithms if you need. So we can look at it both ways. So let's see first how we do it using just the chain rule. So when you do the chain rule, remember the derivative of ln x is 1 over x. In the place of x, I have x squared here. So basically, I just do 1 over the inner function times the derivative of the inner function. So when I simplify this, I get 2 over x. What is the another method of doing this? So suppose say your y is ln x squared, right? The property of logarithm says that if you have log of something raised to the power of something else like this, then this can be rewritten as r times ln m, right? So using this property, I can rewrite this as 2 ln x. And then when I take this derivative, this is right away 2 over x. So you get the same answer regardless. So here I am going to also use the property of, so I'm just rewriting it like this so that it makes it easier for you to look at what's happening. So I'm going to use the property of log. And what is this property of log? It says that if you have log of a quotient, you can write it as the difference of two logs. So using that property, I'm going to rewrite this original expression like so. Now when I take the derivative, I have 1 over x plus 1 minus 1 over x minus 1, and I'm done. Otherwise, I would have had to do the quotient rule and all of that for the inner function, but this way I didn't have to do any of that. All right, so here I had to use the chain rule. So again, if it helps you, you can look at it this way. And then when I take this derivative, the outermost function, this is the outermost function, this is the inner function. The outer function is ln, so I had to do 1 over whatever is the argument, which is ln x in this case, times the derivative of the inner function is 1 over x. Okay. Then here I have the exponential function. As you know, the derivative of e to the power of x is itself, but here I have to use the chain rule because there is e to the power of negative x. So this one would be 9 is just the constant multiple. I just bring it down. The derivative of e to the power of anything is itself times the derivative of whatever is in place of the x. So here negative x is in the place of x. So that derivative is negative 1 minus 5 e to the power of 2x times 2 minus 6 e to the power of x. When I simplify this, my answer should look like this. Okay. So again, I have to employ the chain rule. So when I take this derivative, e to the power of anything is itself times the derivative of sine 2x. So sine is the outer function here. So I have cosine 2x times the derivative of the innermost function is 2. Then I have to evaluate this at pi over 4. So this is my dy dx, right? Now I have to evaluate this dy dx at x equals pi over 4, which means I'm going to do sine 2 times pi over 4 times cosine 2 times pi over 4 times 2. So this sine pi over 2 is 1. So I have e to the power of 1 or just e. Cosine pi over 2 is 0. So this overall answer is 0. Right? Okay. Then I have to use logarithmic differentiation here. So when I use the logarithmic differentiation, what I'm going to do is, the first thing I will do is I'm going to take ln on both sides. Okay. So I take the ln on both sides. And then I use the property of log to expand this. I use the property of log further to expand it even more. And then I take the derivative. So this derivative is 1 over y dy dx equals 10 over x plus 1 minus 8 over 2x minus 4 times 2. So then the final dy dx, I have to move the y over to the other side. And what is my y? X plus 1 to the power of 10 over 2x minus 4 to the power of 8, all multiplied by 10 over x plus 1 minus 16 over 2x minus 4. And that's your answer. Okay, so in this next problem, I'm again going to use logarithmic differentiation here. So the first thing I'm going to do is I'm going to take log on both sides. And then this, using the property of log, I can bring this ln x as the coefficient, like so. Okay. And then I take the, so you can leave it as a product or you can convert it into a square power. So whichever one you want. I'm just going to leave it as a product for now so that you can see it. So I have 1 over y dy dx equals ln x times 1 over x plus ln x times 1 over x. So this is ln x over x, but 2 times. So 2 ln x over x is 1 over y dy dx, which means my dy dx is nothing but y times 2 ln x over x. But what is my y? X to the power of ln x times 2 ln x over x. Okay. All right, so let's use the same thing here. Okay, so let's slow this down. So this is what I'm doing logarithmic differentiation again. So to do that, I'm going to take log on both sides. And then my power becomes the coefficient. Take the derivative. Here I have a product, so I use the product rule. 1 over sine x times the derivative of sine x is cosine x plus ln sine x times derivative of tangent is secant squared x. Okay, so now this one can be simplified, right? Because tangent is sine over cosine, and then I have cosine over sine plus secant squared x times ln sine x. So this, all of this is going to get cancelled, leaving me with just 1. So this will become 1 over y dy dx is 1 plus secant squared x ln sine x. And then finally, I move the y over to the right hand side, and y is sine x to the power of tan x. And then I have 1 plus secant squared x ln sine x. Okay. Okay. Then last problem. So my y is ln square root of 10x. Now square root of 10x can be written as 10x to the power of 1 half. And this 1 half can become the coefficient. Now I take the derivative. dy dx is nothing but 1 half times 1 over 10x times 10. So which is nothing but 1 over 2x. And that's it.